Welcome to Efiwe, excellence without stress.
Hi dearest Efiwe, it's me again, your favorite physics tutor, and today on our journey into excelling without stress, we are going to another topic which is liquid at rest. Today we are going to study a lot about the liquid, the density of the liquid, and some principles that support how the liquid acts, the density of the liquid. Density rho is defined as the mass per unit volume of the material, the mass per unit volume. So for us to know the density of a particular material, the mass of the material divided by the volume of the material will give us the density of that material. So if we're talking about the density of maybe a solid, you know that that's going to be mass over length times breadth times height, because we are talking about the volume. But if it's density and for the liquid also, you know the way we're going to look for the density of a liquid. So density is defined as the mass per unit volume of the material, and density is mass over volume of the material. So after checking the volume of the liquid, maybe using the measuring cylinder or whatever, then you check the mass divided by it. It will give you the density. The SI unit of density is kg per meter cube, but in the laboratory, the smaller units, gram per cm cube, may be found necessary. So these are different states of matter and their density. As we all know that solid has the highest density because its particles are closely packed together. Look at the liquid; it's not as closely packed as the solid, and the gas is very it's so porous, and the particles are not close together at all. So determination of density of a liquid using the density bottle. How can we determine the density of a liquid using the density bottle? So these are the steps we are going to take to determine the density of a liquid. First, determine the weight of the density bottle. Yes, you have to determine the weight of the density bottle, because that is what you want to use to determine the density of that liquid. So you determine the weight of the bottle, that is of the density bottle, as A1 when it is empty. Then fill it with the liquid you want to determine its density. After doing that, then determine the weight of the bottle with the liquid. That is, the first thing you will do is you have an empty density bottle. Just as this is our density bottle, empty, we have to measure the weight. Why? Because we want to determine the density of the water inside. So knowing the weight of the density bottle and knowing the weight of the density bottle and water will tell us the weight of the water alone. You know, you cannot pour water just like that to determine the weight, but what we do is we get our, so first determine the weight of the density bottle A1 when it's empty, then fill it with the liquid you want to determine the density, then determine the weight of the bottle with the liquid. Then the weight of the liquid is equal to A2 minus A1. That is very understandable, because we cannot just determine the weight of this water, because water is a liquid and it flows. You can't put it together unless it's inside the container. You know, water takes the shape of its container, so you cannot just put this water and say, oh, I want to measure the weight of water, unless you put it into a particular container. And by doing that, you have to measure the container when the container is empty, measure it when water is inside, then subtract when the density bottle is empty from when it is with water, and that will give us the weight of the water. So you already know the volume of the bottle, so apply them. Then density is equals to the weight that we have divided by the volume. Make sure to mention the temperature you measured it, because the density varies from one temperature to another. Temperature affects the density of each material. So a density bottle is any bottle of known volume which can be weighed empty and then weighed containing the liquid whose density you wish to determine. Then density will just be mass over volume, and you just determine the density. Yes, you'd first thing is measuring the empty cylinder, knowing the mass, measuring it with water, knowing the mass, then the volume, you now determine it, and that will give you the density of that's how to measure the density of the liquid. Here are the steps to calculate the density of a solid. Now, figure out the volume by measuring the dimensions of the solid. You know now, if it's going to be a square, you know that the volume of a square is length times breadth times height. Then put the object or material on a scale to measure out the mass. You know, this one you can measure the mass because you can put this directly on a scale. Then divide the mass by the volume to figure out the density, mass over volume. So how can we look for the relative density? When you say relative, it means you are relating something to a particular thing. Relative density is the ratio of a substance to the density of water. So we are relating the density of a substance and water. That's what we mean by relative density. Relating the density of something to the density of another thing. That is what's relative. When you are equating one thing to another. That's relative. So relative density is a ratio of a substance to the density of water, Also, relative density can be defined as the density of a substance divided by the density of water. It's still the same thing, and it can be mass of substance divided by mass of equal volume of water. The mass of the substance divided by the mass of equal volume of water. It can also be the weight of the cork in air divided by the weight of equal volume of water, or the weight of cork in air divided by upthrust on cork. So all of this is just giving us relative, how we are relating the density of one particular substance with the density of another. That is called relative density. We are not using the mass of the same thing, and so this relative is density of one divided by the density of another. So relative density is the ratio of a substance to the density of water, and that's about relative density. An example is here: a body weighs 0.3 Newton in air and 0.25 Newton when fully immersed in water. So just view this. This is a body. When it is normal, it weighs this, but when it came into its water, it became what? Lighter, and it was what? 0.25 Newton when fully immersed, and 0.27 Newton when fully immersed in liquid. Okay, it was fully immersed in water. When it was in water, it was 0.27 Newton. Then when fully immersed in a liquid, the liquid can be oil, it was what? 0.27 Newton. Calculate 1, its loss in weight in water. 2, its relative density. 3, the relative density of the liquid. So the relative density of this body and the relative density of the liquid. So loss in weight in water is equals to what? What was the difference? In water, it was initially in air, it was 0.3 Newton. That's the normal weight of that body. When we put it inside water, it became what? 0.25. So the loss in weight in water was 0.05 Newton. So the second thing is the relative density of this body that we came. So it's going to be weight in air. It's weight in air divided by the weight of equal volume of water, and that is it, which is what? 0.3 divided by 0.05, which is 6, and that is the relative density, because density and density are the same unit. That's why relative density does not have a unit. So relative density of the liquid now is upthrust in liquid divided by the upthrust in water. And what is upthrust? Upthrust is just the difference between the weight in air and the weight in water minus the weight in air minus the weight in liquid. So it's just a division. So this is the weight in air minus the weight in that liquid divided by the weight in air minus the weight in water, and it will give us the what? Relative density. So a body weighs this in air. You can just visualize this. When the body was normally in air, this was its weight, and when it was in water, it became this because it became lighter when fully immersed in water. And then in that particular liquid, maybe oil, it became 0.27. So what is its loss in water? Loss is just what was the difference between its weight when it was in air and when it was in water, and we did the subtraction and we got it as what? 0.05 Newton. The next question is the relative density. And we've talked relative. It's relating it to something, relating it to the density of water. So relative density of the solid is equal to its weight in air divided by the weight of equal volume of water. The weight of equal volume of water, which is 0.3 divided by what? 0.05, which is 6. The loss of weight in water gave us 0.05 Newton, and that is the weight of the equal volume of water. You're going to understand this later. So its loss in weight, it's relative density, and we've gotten that. Then the relative density of the liquid. Relative density of the liquid is the difference between the weight of that solid in air minus the weight of the solid in liquid divided by the weight of that solid in air minus the weight of the solid in liquid, and that gave us 0.06. Archimedes principle. Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. So what this is telling us is that Archimedes principle is trying to say that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, that is when a body is submerged in a fluid, either partially or fully submerged, the weight of that fluid is equal to the weight of the fluid that the body displaces, and that weight acts upward direction at the center of mass of the displaced fluid. And that is what Archimedes principle. This is telling us, this is trying to explain what happens when a body is either submerged partially or fully in water. So the weight is equal to the upward buoyant force, the upward force. You know what? For everybody, there is an upward force and there is a downward force. That is what it's trying to tell us. That let's draw that on our board. Let's assume that this is a body. Let's draw that on our board. Sorry, on our board. So this is what the Archimedes principle is trying to tell us. We have a body. A ball, maybe this is a ball, it's submerged. You know that for everybody, two forces are acting according to Newton's law. One force will be pulling you down, one force will be pulling you up. So this is what Archimedes principle is trying to tell us, that if a body is partially or fully submerged in water, the weight, the upward force weight, is what the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. You know, when we were trying to explain the volume, when we're trying to explain the volume of an irregular solid, we try to tell you that, okay, if a solid is thrown into a bucket of water that is filled, you can use your Eureka can to do that. The volume of that solid is just the water that was displaced. You know, if a bucket of water is kept on the table and you throw you throw something inside that water, little water will be displaced. The water that poured away is the volume of that solid that was thrown into the water. So the same thing, Archimedes said that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal. That force is equal to the weight of the fluid that the body displaces. That is, when a body is inside a liquid, the buoyant force, the upward buoyant force that is exerted on a body immersed in a fluid, whether partially, is equal to the weight. Whatever liquid that body displaces, the buoyant force is equal to it. The buoyant force is equal to. So the value of thrust force is given by the Archimedes law, which Archimedes of Syracuse of Greece discovered. When an object is partially or fully immersed in a liquid, the apparent loss of weight is equal to the weight of the liquid displaced by it. So that is what they are trying to tell us, that the weight of that solid is equal to the weight of the liquid it displaced. So apparent weight is equal to weight of the object in air minus the thrust force or the buoyancy. So let's take this example. Calculate the resulting force if a steel ball of radius 6 cm is immersed in water. This steel ball was immersed in water, so you know that it's going to be an upward force and there's going to be a downward force. And now we're trying to use the Archimedes principle to prove this. So the radius of the steel ball was 6 cm. We converted it to meter and it gave us 0.06 meter. What is the volume? Volume of a steel ball is like a sphere, is 4/3 pi 4/3 pi r cube. Then getting the volume, we got it as 9.05 times 10 raised to minus 4 meter cube. Then acceleration due to gravity, which is a constant, was 9.8 meter per second square. Then from Archimedes principle, we have it that it's equal to the density multiplied by the acceleration due to gravity multiplied by the volume. So the force of the ball is equal to what? This, which is the density multiplied by the what? Acceleration due to gravity multiplied by the volume, and we have the density, the resulting force, as 8.87 Newton, and that is the resulting force, Practical applications of Archimedes principle. These are the practical applications. Archimedes principle is used in designing of ships and submarines. They are to be made of a specific dimension so that in spite of the large value of density of steel, the ship will float in water. Lactometer also work on Archimedes principle, as adulteration causes a change of density which can easily be identified using this device. Archimedes principle provides the principle of working of a hygrometer, which is used to determine the density of fluids using water. So upthrust, volume of a liquid displaced times density of the volume will give us the upthrust. Density times what? Volume of the liquid displaced times the density of the volume times acceleration due to gravity, and the volume of a liquid is displaced is equal to the volume of objects immersed in liquid. Upthrust is saying that The volume of liquid displaced is equal to the volume of objects in mass in liquid. That was what we have tried to say. If you throw something into water, the volume of that particular object is the volume of the liquid it displaces. The volume of the liquid it displaces. Let's try to draw that on our board. If we throw this, so this liquid now, throwing it into little water will pour away. The volume of this ball is the volume of the water that poured into this bucket, and that is what we are trying to say about the upthrust. So we said upthrust, which the formula is volume of the liquid displaced multiplied by the density of the liquid multiplied by the acceleration due to gravity, and the volume of the liquid is equal to the volume of the object in mass in liquid. He said this is equal to the volume of the object was in mass in liquid. If it is fully submerged in a liquid, then the volume of the liquid displaced will be equal to the volume of the object. So look at it now. We have two forces acting on the object. This is the object in liquid. We have an upward force and we have a downward force. So force acting on top of the body due to fluid is equal to what? Density multiplied by the area. And don't forget that your density is what? H density G and multiplied by the area, and net force is equal to upthrust, and this is the formula. The height H2 minus H1. This is the first height and this is the what? Second height, that is from this point to the top of the water. So and is equals to the net force is equals to the upthrust is equals to H2, this point, minus H1 multiplied by the density multiplied by the acceleration due to gravity multiplied by the A, and that is net force is equals to the upthrust. This is the formula for the upthrust. The force acting on the bottom of the body due to the fluid is also equals to what? P, density multiplied by the area, and that is just the H2 multiplied by the density multiplied by G multiplied by A. So this is all the forces acting on this particular body submerged in water. An upward force, a downward force, and the net force at the center, and that one is equals to the upthrust, and this is the difference between this height and when it is submerged in water, H2 minus H1 multiplied by the density acceleration due to gravity and A, and this is all about liquids. Thank you.